There's a gigantic storm in Jupiter that is 11 times bigger than the Earth and has been raging for over 100 years. But NASA has discovered that there are more mysteries to this gas giant than meets the eye. Jupiter is more than twice as big as all other planets combined, with its vast stripes and swirls that are usually cold, surrounded by ammonia ice clouds that can travel long distances and put humans at risk. The fatal ammonia is just the tip of what lies in this ringed world. Fifth in line away from the Sun with its large spinning energy, it is no longer news that 11 planets the size of the Earth can fit across Jupiter's equator. While the Earth completes a rotation once every 24 hours, Jupiter does that within 9.5 hours, making a day on Jupiter quite fast. You've probably seen beautiful photos of the planet and may likely think that a trip to Jupiter and back is a walk in the park, but this planet also has a strong internal heat source and a powerful magnetic field that produces intense radiation belts, which makes studying it from close range a challenging task. We know Jupiter cannot support life, but some of its moons have oceans between their crusts. So does this mean that humans can possibly live on some of these moons? Well, NASA's Juno orbiter is still on a mission to explore and discover more about this gas giant, so this video will give you a head start. Jupiter has long been a subject of scientific interest. Aside from being a gas giant with a unique and thick atmosphere, composed primarily of hydrogen and helium with small amounts of other elements, Jupiter also has many moons, including the 4 largest in the solar system: Io, Europa, Ganymede, and Callisto. The bright colors seen in broad bands across Jupiter are likely plumes of sulfur and phosphorus-containing gases from the planet's heated core. White clouds in the light zones are composed of frozen ammonia crystals, darker clouds are found in the dark belts, and blue clouds can be seen at the deepest observable depths. In 1610, Galileo decided to gather his tools and make the first detailed observations of this massive planet. This he did with a small telescope and was able to spark curiosity in the minds of astronomers as he made a careful observation of the Moon, Venus phase, sunspots, and the countless galaxies in our Milky Way. Galileo discovered that Jupiter has 4 large moons orbiting around it, which he named Medicean stars: Io, Europa, Ganymede, and Callisto. The atmosphere is complex with belts and zones of alternating lights and dark bands, all of which are as a result of strong winds and turbulence in the planet's atmosphere. As the fastest spinner, this gas giant rotates on its axis quickly, completing one rotation in just under 10 hours, much faster than any other planet in the solar system. With a constantly changing appearance, various spots and irregular shapes on its surface, Galileo recognized that its clouds and storms are similar to that of the Earth. Curious about the Sun, he flexed his telescope more by pointing it directly toward the Sun and discovered that the Sun has sunspots, which appear to be dark in color when you look closely at it. His observations of Jupiter were some of the first telescopic observations of any planet, and over time have played a major role in the eventual acceptance of the heliocentric model of the solar system, which proposed that the Sun, not Earth, is at the center of the solar system. Galileo's discoveries propelled other explorers to make a move because they realized that studying Jupiter is crucial to our understanding of the origins and evolution of the solar system, and will also help to unlock the mysteries of this fascinating world. There and then, NASA came on board and launched the Juno mission. The Juno mission is NASA's most recent mission to Jupiter, a spacecraft that was launched on August 5, 2011. The goal of the mission was to study Jupiter's atmosphere, magnetic field, and the planet's interior structure. Now, exploring Jupiter is not as easy as it may seem, and NASA knew this already. So they made the exploration mission easy for them by using some key instruments on board. As a gas giant, Jupiter lacks a true surface and is composed mostly of gases and liquids. Attempting to land or fly through Jupiter would be impossible due to the intense pressures and temperatures that would destroy any spacecraft. Since Juno uses a solar-powered propulsion system, it has helped reduce fuel and other requirements needed for spacecraft, allowing the probe to carry more scientific instruments, including a magnetometer, a microwave radiometer, a gravity science instrument, a Jovian infrared auroral mapper, a Juno cam imager, and an ultraviolet spectrograph. NASA wasn't ready to explore this gas giant alone, so they included the Juno cam imager in their instruments list. With the Juno cam imager, which is a public outreach instrument, the public will get the opportunity to participate in the mission by requesting images of specific areas on Jupiter and voting on which areas should be photographed. On July 4, 2016, Juno successfully entered Jupiter's orbit, making it the second spacecraft to do so after the Galileo spacecraft got to Jupiter in 1995. The spacecraft was launched in a polar orbit around Jupiter, which allowed it to make repeated flybys over the planet's poles and gather data on the planet's magnetic and gravitational fields. These measurements will then provide insight into the planet's deep atmosphere and interior structure, including the distribution of water and other materials within the planet. Scientists believe that at a certain depth in Jupiter, the pressure is so high that it causes hydrogen atoms to lose electrons, making the liquid a conductor-like metal. Jupiter's rapid rotation is believed to produce electrical currents that generate a strong magnetic field. However, it is still unknown if Jupiter has a solid core deeper down or is primarily a hot, dense mixture. With the launching of the spacecraft, NASA hoped to determine the amount of water in Jupiter's atmosphere, investigate the atmosphere and weather patterns of Jupiter, and search for evidence of a solid planetary core. Jupiter's moon, Europa, is also a major focus of study. NASA scientists believe that the icy moon could harbour a subsurface ocean of liquid water, and studying this moon could be key in finding any sign of life in the solar system. Juno's orbit around Jupiter is highly elliptical, taking the spacecraft as close as 2,600 miles to the planet's cloud tops and as far as about 18 million miles away. This closeness has given the spacecraft an opportunity to study Jupiter's polar regions while avoiding exposure to the planet's intense radiation belts. Since its launching, the spacecraft has travelled nearly 2.8 billion miles to reach Jupiter, making it the farthest planetary flyby in history at the time of its launch. Juno has revealed some pretty cool facts about Jupiter so far, some of which is the existence of intense storms at Jupiter's poles, including giant cyclones that are up to 600 miles wide. Earlier missions did not observe these storms, and their presence challenges current models of Jupiter's atmosphere. There is also evidence of powerful hydrogen and helium jets extending deep into Jupiter's atmosphere. These jets are thought to be responsible for the planet's colourful bands and are some of the fastest winds in the solar system. Perhaps the most shocking revelation is that Jupiter's magnetic field is much more irregular and chaotic than previously thought, with large areas of weaker and stronger field strength. Also, the lightning strikes in Jupiter are much more powerful than those on Earth and have been detected at frequencies much lower than those used by terrestrial lightning. Jupiter's gravity field reveals that the planet has a distinct and complex internal structure with regions of varying density, including a possible metallic hydrogen layer in the core, and there's a strange, uneven distribution of ammonia in Jupiter's atmosphere, with some regions having much more of it than others. Initially, the Juno mission was planned to last for the duration of 1.5 Earth years, with the spacecraft making a total of 30 orbits of Jupiter. But due to the spacecraft's successful performance of completing more than the speculated 30 orbits, NASA decided to extend the mission multiple times and has been ongoing since 2016, still collecting and sending data. By studying more of this planet, NASA hopes to better understand the planet's formation and evolution, as well as the origins of the solar system. The mission is not ending anytime soon, and NASA is known for not giving up either.